Okay, round 2. On number 10, if you work things out and plug in your 14 for G, 5 for H, you end up getting these two to equal 17 apiece, which works out. But then we plug in your H for these two. We plug in, one gets a 6, one has a 7. They do not match, therefore no. That opposite sides aren't congruent. Since they're not congruent, this cannot be a parallelogram. Moving on, which leads us to a couple of more theorems. One of the theorems is if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And then we have if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So I want you guys to be able to see what I'm... Okay. So you guys try these based off what we just saw above. Okay, so we're talking about the diagonals bisect each other. Okay. And opposite sides of a quadrilateral both congruent and parallel, then it is a parallelogram. So apply that to the triad problems below. Push pause, work them out, check them when you get back. Okay, here are your answers and worked out problems for that. As you can tell, one side of I did in blue. B, D I did in blue. This half is going to be, they're bisecting each other, so this half is going to be the same as this half. That's why I set them equal to each other. And then I worked it out. I got P is equal to 1. I substituted that back in to the problems. And notice I got 8 and 8. In green, I did the AC. Again, same situation. The top half is going to equal the bottom half because it's bisected. Bisect means cut something into two equal parts. So I did the green down here in the bottom. I got Q is equal to 2. I substituted that back in and got 7 and 7, which is also equal to each other. So yes, this is a parallelogram. Did I need to substitute? No, not necessarily, because the problem says it is a parallelogram, so I really didn't need to. I did it anyway just to show you that yes, if you plug the numbers back in, then it works out. As you can tell in number 12, this is asking you, is this a parallelogram? And explain. Well, let me see if I can actually get this to where you can see it. So what I did was I added these two because they're consecutive angles. If they're consecutive angles, they should equal 180. So that's what I did here. I added them up and it equaled 180. Okay, so yes, they are supplementary. If they're supplementary, then these opposite angles should be the same as well. Now another thing that showed us that is that we have supplementary angles and we also have opposite sides being congruent. Okay, so based off the theorem above, opposite sides of a quadrilateral are both congruent and parallel, then we have a quadrilateral. Okay, so this actually tells us that yes, this is a parallelogram. Number 13, is it a parallelogram? Let's take a look. Now we talked about diagonals bisecting each other, creating two equal parts. Well, we have that here and here. Now, but the real question is, the next question is, it bisects each other. So is WY bisected? May look like it, may pass the eyeball test, but there is nothing in this diagram that tells you that WY is actually congruent to each, or it bisects to create two equal parts. Because we don't know that they're two equal parts, it does not fit the criteria of what we know to prove that a parallelogram. So this is a no. Only one diagonal is bisected, not 2. So that would be your reasoning, you're explaining to that. Okay, you guys try the next two. Pause, come back. Again, I'm hoping you actually stop there instead of just letting it play. On number 14, no, this is not a parallelogram because we need 2 sets of opposite angles to be congruent. Well, we noticed that with angle A is congruent to angle C, but we don't know if B and D are. So, in order for this to be a parallelogram, we need 2 pairs of opposite angles to be congruent. This figure only has 1, which was angle A and angle C. So no, that is a no. Let's scroll down to number 5 or 15. Yes, this is. 1, consecutive angles are supplementary. If they're supplementary, that means that these lines are parallel. It's a great arrow, I know. These lines are parallel. Not only are they parallel, but it tells us that they are also congruent. So we have consecutive angles are supplementary, which means they are parallel. The same side interior method. Yeah, I know, it came back. And then we have the FG and EH are congruent based off what the diagram tells us. So this is a yes. Okay, so now we have a little bit of a word problem, which don't be terrified. There are word problems, but still roughly the same thing, just with letters and words. A mechanic raises a truck using a lift. For safety, the floor must be horizontal and the top of the lift must be parallel to the floor. Is the lift shown to be in a safe position? Well, we know that those are congruent, so we have opposite sides to be congruent. But now let's check on these angles. Okay, so we have 105 and 75. Is that supplementary? When you add them together, 105 plus 75 equals 180. So yes, they are supplementary. So we have consecutive angles to be supplementary. So we know for a fact that these two, the top and the bottom, are parallel. Okay, so if they're parallel, then we also have a set of angles and a set of congruent sides. That's what we learned. If you go about 2 back, this theorem right here, parallel congruent, that's what we have. So now that we know that this is a parallelogram, then the top shelf that the truck is on is going to be equal to the bottom of the lift. So they're going to be equal. This is a parallelogram. The main thing we need to know is that these two things are parallel. Okay, if they're parallel, then basically you're going to have a flat top and it won't have any tilt to it. Therefore, it is safe. Is the lift shown in a safe position? Yes, because the bottom and top are parallel, therefore the truck will not roll off. It is safe. Okay, try the next one on your own. Pause, come back. Okay, for this to be parallel, it looks like this one is using the diagonals. Now, are the diagonals bisecting each other? Okay, we have a 10, and its same line over here is also 10. Now we also have 20 and 20 here. Okay, so now it's asking you, the carpet builds a table. Is if the floor is level, how likely is it the ball be placed on the top and will not be rolled off? Because those diagonals do bisect each other, then this is a parallelogram. So this is a parallelogram, then we know that the top of the table and the bottom is parallel to each other. Therefore, there's no tilt to it, and the ball will not roll off. I know it seems weird to say because of the way the diagonals are, but if they truly bisect each other, it creates a parallelogram. Therefore, it will be flat on the top, and it will be parallel to the bottom. And here's the answer. No, the tabletop is parallel to the floor. The ball will not likely roll off. Oh, poor Rochelle. Gotta, we look at this and it says the parallelogram because the diagonals are congruent. Well, we don't know that the diagonals are congruent. There's not enough information to tell us this. Okay? As far as we know, this could be an isosceles trapezoid. We don't know. It looks pretty close to possibly could be one. But there's not enough information. So, nothing in the diagram proves that BCDA is a parallelogram. And that's my attempt at drawing a parallelogram. That's poor, but that's probably the best I can do. So the rest of the reason, why that this is wrong. Therefore, she cannot make the conclusion. So her conclusion is, or her assumption is wrong. All right, now we're down to the last page. Is the information in the diagram enough to show that W, X, Y, Z is a parallelogram? Explain. Yes. The main reason why is because in parallelograms you have to have two pairs of opposite angles congruent. X, so angle X is congruent to angle Z, and then we have W and Y, so angle W is congruent to angle Y. So both opposite angles are congruent. All right, so I'm trying to rush through this because I'm about the end of this 15-minute video, and we got a few more to go. So do the rest of the page and pause, come back for results. On 21, D must be 115 because it is an opposite angle to angle F. So in order to be a quadrilateral, it has to be a parallelogram. They have to be the same. So it's 115. On 22, angle E is a consecutive to F, and it has to be supplementary for it to be a parallelogram. So I did 180 minus 115, and it equals 65. On number 23, JK, which is this line, must be the same as ML. So in order for them to be the same, I set them equal to each other, and I did that in green. Notice that X is 4, so then I plugged back in. I got 10 for JK and 10 for LM. Since they are both congruent, then this works out. So what must JK be in order to be a quadrilateral? JK must be not 4, but 10. And on the bottom it says JL needs to be what for it to be a parallelogram? JL is the whole diagonal. So what I did was I already took my X and plugged it in. So then I plugged it in and got 2 times 4 minus 1, which is 8 minus 1, which is 7. But 7 deals with JA there. But in order, we're looking for JL. So JL is twice that amount, and it is 14. Okay, so that is the end of this particular lesson. You can start working on your assignments. Have any questions, ask Miss Whitmer because she is a genius. Hopefully I'll see you on Thursday. Sleepy-ish. Very sleepy-ish.